everybody! I'm here in the new episode of Deploy Friday because every day is a good day to deploy application easily in the cloud with Platform SH. Today, let's talk about integration partner with Apache Camel, Broker, and Apache Kafka. Right? I'm here with several amazing guests. I'm here with Hugo Guerrero. Hello, Hugo. How's it going?
Hello.
And also I'm here with Christina Lin. Hello, Christina.
Hello.
And also beyond that, I have my colleague from Platform Stage, Larry. Hello, Larry.
The world.
Hello, world. Okay. So let's start with the first questions. And the first question is, what is Apache Camel?
Right. So I'll answer that question. So Apache Camel, it's a project. The most popular project. I say it's the most popular project on Apache community. So it's been around for a while, and it solves one simple question, but that's what developers were often using because it solves the connectivity problem, right? So if you're a developer, most of the things you do is you're connecting from one point to the other. Say you're connecting from a Salesforce, sending it to a database, or you're collecting a message from a Kafka broker, and then you're sending it off somewhere in your somewhere, or sending it to AWS or whatever that was on the cloud, right? Or you're just doing a lot of back and forth integration. That's why we call integration. And Camel helps you to do that, right? So most often when we write a Java applications, you need to set up the libraries, you need to configure the libraries, and then you write the integration code in between, and then that's what you do. But and then every single time when you write it, you have to rewrite everything again. So you're reinventing the wheel, right? So basically, Camel provides you with this library. So as a Java developer, you just include this library, and then you get to have all this pre-created for you. So all you have to do is just in your program, we have something called Java DSL. So the Java DSL is very simple to understand. The syntax of Java DSL is it's coming from and several to. So basically, what you're describing is I'm collecting my data from here and I'm sending it off somewhere else, right? So that's basically what Camel is. And then when you define, say, I'm getting it from the Salesforce, you don't have to do all the API connection to Salesforce and all that. All you have to do is just configure all the things that's needed. And then the Camel is going to do all the hard work, all the heavy packaging for you. So basically that's what Camel is. It's making your life a lot easier for developers, so you don't have to reinvent the wheel for doing integrations. And also, it's not it. When you do integration, there's a lot of things you want to do, right? You want to you want to transform your data, because Salesforce doesn't necessarily talk in the way that the other application in your services does. Sometimes they have different APIs. So you want to do transformation of the transformation of your data. And Camel does that for you automatically. So all you need to do is just tell Camel, this is how I want to transform my data to this part, and it's going to do that for you. So it's helping you a lot when you're doing connections, integrations between places.
Well, good to know. I,
So
I,
is it
I have one question about that. Oh, go ahead, Larry.
just to make sure I'm understanding? So does it have an intermediary internal format? Like if you're pulling data out of Salesforce and pushing it into Zendesk,
Right.
to use two random examples, then does it have like a Salesforce plugin and a Zendesk plugin, and those two know about each other, or is there some internal format that it maps data to translate
Right.
it across?
So basically you get what we call components in Camel. So it's actually what you said, what you described as a plugin, right? So it has all
Okay.
that. So you basically you plug all this in your Camel. You can select it by basically depending on the framework and runtime you choose, it just pulls it in there. And then in the middle, like the format, you can actually there's many methods you can define how your formats transform, right? And then we also have toolings to help you to do the transformations. There's drag and drop. So in Salesforce, it has a predefined data format. And say in Zendesk, it has its own predefined format. So Camel tells you that, right? And then all you have to do is just map between what kind of data you want to extract from Salesforce, what kind of data you want to send to Zendesk, and then it's going to do that for you.
Okay.
Okay, nice. When I read the documentation, the Apache Camel documentation, it says something about enterprise integration partners.
Right.
And that's my first question, my second question indeed. What are these integration enterprise partner? Why should I learn about that? How should I use that?
Right.
And where
So
that come from?
it's a right. So we'll think about integration in a lot of cases. They it's a lot of duplications. People are doing things all over and over again, right? It's similar to what you're doing with the libraries. And then if you think about integration, what does it do? Basically, this content-based routing. So it's routing your data, your messages or your data to different places. Something that's already done. Like people does that all the time. So why do I need to reinvent the wheel and recode everything every single time, right? And then you also have the dead letter queue. You want to send your exception messages somewhere else. And there's also other patterns. There's other things that people commonly do when they do integration. So that's what enterprise integration pattern is. It finds that patterns for all what people do in integrations, and it just specified that. There's a book that describes what people do in the enterprise, that all this integration things people do. And what Camel is very good at is it implements that. So it takes whatever that patterns that people sees, and you can actually use that pattern in Camel. So say for instance, content-based routing, Camel already have that built in, so you don't have to code it like the if else when if coding in that. So Camel does that for you. Like Camel has the CPR, you can put in, okay, this is where I'm extracting the data and this is where I'm sending it to. So that's all done in the enterprise integration, in the patterns in Camel. So Camel helps you to implement all that without you doing it over again.
Oh, nice. So I have my Java code, and then I decided to, I don't know, receive some information from any kind of web servers and transform that information to any kind of information, then move forward to any kind of
Right.
service like XML, JSON file, something like that, right?
Yep. And then you can decide where to send it to, because there's so many different ways you want to send it to. Sometimes you want to cache it and then send it over somewhere. Sometimes you want to do wiretap. So you want to send another separate type, a separate set of the copy, the same thing, to another places. We call it wiretap. So there's a lot of different message flow when you want to try to do integration. So it kind of defines that pattern. So say for wiretap, you have that in Camel. So Camel is going to automatically send that message and copy that message and send to two different places. So you can do that with Camel. So you don't have to manually do that. So in Java, in Java applications, you need to manually copy that file, right? And then send it to a place first, and then send it to another place first. But Camel does that when you define that particular patterns in Camel.
Okay. Think about Java developers. What are the runtime choice? I mean, can I use Spring? Can I use Quarkus? Can I use what kind of frameworks does Apache Camel have support to?
So the answer to your question is yes, I can use both of them. I don't care. For us, it's just a runtime, right? Because I think the what Camel is really great is that we give you freedom of choices, right?
Wow.
You can either run it on Quarkus. We worked on something called a Camel Quarkus extensions. So you can actually build your code pre-built, pre-recorded all your build time information, Quarkus and all that in Camel. But then you also have choices. If you want to run it on Spring Boot, you can do that. And then if you want to run it on just pure Java main, we do that for you too, right? So it's basically you can run like any choices, any preference of your choices. And it's not just that. It's not just the Java runtime that the freedom that we give you. We also give you on the DL side, DSL side as well. So you don't actually have to write it in Java code. You can also write it in XML form. You can also write it in YAML, since YAML is so cool right now. It's the next XML or JSON, whatever, if you prefer to write in YAML, or you prefer to do it in Groovy, whatever type of languages you want to use, you can actually use that. And then Camel is going to convert that and run that on your JVM. Or other runtimes you want to prefer, or native code if you want to use Quarkus, right? So that's the freedom we give you.
Okay. One question about that. So basically, I can put the library as I want on my dependencies, and Apache Camel is ready to go, right? Is there any easy way to give some result written as any kind of API to any kind of language? I mean, I consume some web servers received by Apache Camel. So does Apache Camel has any kind of uh, web API to consume to another language,
Um, to consume to another language.
like
Uh,
PHP, JavaScript, Node.js, or even Java, but another application itself?
You mean for writing custom components?
Yes, something
so
about components.
Yeah.
for writing components, I think it's mainly Java for now. Um, so that's basically because it's library. So we're trying to pull it into a library. So basically for the components, it's still Java. But for Camel, we don't really see the endpoints as different languages. We just kind of see them as a protocol, as a data format type, right? So if I'm receiving from a web services and I'm sending it off to somewhere, I don't care if it's written in Python or whatever language that is. I'm just sending it off to them depending on what kind of protocol they use to receive. And that's what I do. So I support also Camel supports a lot of different protocols like AMQP, MQTTs, RESTful services, HTTP, SOAP, whatever. It's just the protocol. So I don't really like for Camel. I don't really care about what kind of things they're using to write the application.
Okay, I got it. So basically, Apache Camel is integration between database, web servers, Apache Kafka, and also any kind of message broker, right?
Yep, we
And
see a lot of
let's,
cases connecting to Apache Kafka. So that's a
yes,
lot.
Speaking of,
speaking of,
Speaking of
so,
Kafka.
well,
Hugo, that's your cue.
Yeah, that's
yeah,
me,
that's
right?
your space.
Well, actually, yeah, I was just Christina was right. So one of the main cool things that Camel has is has all these components that allow you to talk to almost anything, right? So they have converters or protocols or components to talk with all these protocols, WebSockets, AMQP. For example, one of the things that you usually do when talking about connecting microservices or applications or cloud native applications, it's actually being able to handle all these protocols because even though HTTP REST APIs is like the most common way to use your endpoints to connect to other systems. There are still a lot of systems out there that talk different protocols, right? And for example, one of this type of custom or proprietary protocols is actually the Kafka one, right? It's not a standard. It's just being by Kafka. It's a binary protocol. So the importance of having this connectivity, it's great because you will certainly be targeting, for example, in your application design, event-driven architecture, right? Where you're able to decouple systems and applications, not just from the technology point of view, which can use different protocols to get data in and get data out, but also in the runtime space where you can have a application sending messages into your event-driven architecture and then another application consuming that in a later time, right?
Okay, so let's put a hard question right now. So because Camel does support TBUF, right? So Apache Kafka, and also any kind of message broker. When should I use Apache Kafka? When should I not use Apache Kafka instead of any kind of message broker? What the
Oh,
main difference between them?
yeah, well, it's a very good question. It's actually one of the first things you need to know when trying to get into this kind of moving sands, right? Well, it's important to know what is Apache Kafka, right? Apache Kafka, it's a tool that is specialized, created by LinkedIn to being able to process a huge amount of what we now call events happening on their website, right? And with LinkedIn. So they already have this, or we already had this approach to messaging and how to handle this asynchronous communication through message brokers, or what we used to call message-oriented middleware, whereas this component allows you to send information and then share that information with other systems. So what happens is when they have this requirement to have a high throughput, high scalability way to handle those messages. So they decide to modify the traditional broker approach to make it able to solve those questions. So what you need to do is actually think about what is the use case of your events, or your messages. What type of events are you handling? Because that will certainly help you decide which kind of architecture will be better suitable for you. In our case, we have figured out that there's like 3 different types of events that you want to handle, right? The first one is like the volatile events, the events that needs to be consumed if they're available in that moment of time. And if not, if there's no one to consume those events can be lost or can be just discarded because they are actually not impacting your business, right? Like, for example, IoT devices setting temperature to a process that is just calculating average temperatures for a day. If you miss 2 or 3 records because the system was down, well, that is not a big impact on your business. But then there's other type of events where you actually care about, the event needs to be delivered to the actual application that requires that information. So that's the most common approach for broker like or ActiveMQ or any other MQ type of broker that you think about, and that will take the message, take ownership of that message, and then be sure that it is delivered to the actual consumer. We call them consumers, applications that are listening to those events. And the broker has a lot of logic inside to being able to handle that specific use case where you need to be aware that who's listening to which events, how to actually deliver the expected event, what was the last event it was delivered to a specific consumer. In the case of Kafka, because they were looking for a different approach, they were just handling the huge amount of events flowing through the system. They just wanted to, being able to write them down in the broker and being able to deliver to the consumers as fast as possible and as scalable as possible. So what they did is they stripped down a lot of the logic from the broker that was in the previous case in charge of following who was connected, who was listening, what is the last delivered message, and they delegate all that information, all that logic into the actual consumers and producers, right? So in that way, the broker was stripped out of that specific logic, and it was able to just focus on receiving messages, storing messages, and then delivering messages to consumers. So that did open possibilities to a specific use case for those events that is called repliability, where you can because now the consumer is expected to know which message to read, which message to receive. Then and they need to keep those messages available for any other consumer that could be at a different time. They had this option to keep the messages for a longer time, so other consumers can get and read those events. So in this case, that's the difference, right? If you need to treat your events and your messages like your pets, like you need to be aware who's receiving those, who's using those, then you need a broker, a traditional message broker that is GMS type of API. But if you really want to treat your messages in a cloud native way, where you have this cattle approach where I need people to actually take care of their own messages and how to read them, then Kafka, it's a different tool that certainly will be able to fit you better with these replayable events. But be aware of this, that Kafka, because of its distributed nature, it's like microservices, right? You need to be this high to be able to use Kafka, because it's not like a broker. You can just handle like 100 messages. Kafka was designed to have millions of message throughput. So it will certainly require distributed components like Zookeeper and so on. So it requires a little more of knowledge of your applications and how to read the messages and so on. So it also requires a different type of approach from the developer and the architect design.
Okay. A
So I
lot
suppose
of people right now mention about Kafka, Kafka, Kafka. If you go to any kind of developer blog, any kind of article, zone, InfoQ, JSON, whatever, we can see a lot of Kafka tutorial, Kafka articles, Kafka everything. So why Kafka becomes so popular among the cloud developers?
Well, there are different approach. So one of the things that actually help a lot when talking about like cloud native development, it's this benefit of being able to easily scale, right? And that's one of the difference that I mentioned before. When you're just focusing on a specific task for the broker, then the ability to scale that specific or specialized feature, it's easier, right? So it's very easy to scale, and also allows you to implement some patterns with these replayable events that allow you also to implement different type of use cases on top of that tool. But
And we also have a lot more scaling in the current situations, right? Because now, before at the time for the broker, it's more on the ESB type of older implementation, right? And you want to make sure that your message was delivered, and the message that's transferring, like the throughput of the message, is not as much as that we got today. Because today, where we have all this, the devices sending streams of events, right? And we need to capture all that. So having a larger throughput of medium for us to actually capture the events is a lot more important. So that's why I think Kafka has become a lot more popular. And like Hugo said, the ability to replay the actual events is important as well, because we can do a lot of things on top of it, like think about AIML, right? Because you can do a lot of data sets, analyze and with all these events. So we need a place to store all these events. So that's kind of why we need all that, the capabilities provided by Kafka, right? So yeah, because hosting a Kafka is actually a lot harder than hosting a broker, in my opinion, because I feel like you need to have a lot more knowledge on the status, the petitions, all that kind of stuff. You need to make sure that your operation person understand that, and doing a backup for Kafka is a lot complex than the broker. So why do I need to make that sacrifice? Because right. So why do I need to do that? That's because of the throughput and the ability to have the replayability ability, and then also the ordering is important as well, because sometimes the order of the events is important, and Kafka can make sure that happens for people receiving the event. Say if I do want to do complex event processing, right? And how do I make sure that the events comes in order that that, because that makes sense for me, right? Because how do I know that this purchase is after that purchase? So I need to make sure that events, the order is important. So Kafka helps me to do that too, right? So that's why I think people are starting pivot towards the Kafka implementation.
right, actually, what one of the use cases that Christina mentioned was the event stream processing, right? That's something that came into play recently when this explosion on the big data size, right? The difference was that in the past, or a few years ago, we had to have these ETL type of pipelines where you just collect information, transform that, and then move into a data lake or a data warehouse, when you are able to do this, the processing of those events when you have all that information. But that makes your information being stale, because actually what is happening on the other side has a delta on time that could be just like minutes, or it could be just also days, right? With this ability of doing the replays and having information flowing through your system, you start to short those processes, and then now you're able to add on top of your Kafka topics these streams applications that can do that even stream processing. So it also changed the way you can start processing your information, trying to get closer to the real time. And now that we are in a fast world that needs to take decisions very quickly, having the ability to take decisions quicker, it's also a benefit from your application perspective.
So for those not familiar with the term, can you explain ETL?
Oh, ETL is this three words that we use for extract information from a data source, transform the T, and then load that information into your data warehouse or your final repository. So ETL, it's extract, transform, and load. It's just a way to process and construct data pipelines in the past.
Which sounds exactly like what Camel is designed to do. If I'm
Yes,
understanding correctly.
exactly. And I hate it when people relate Camel to ESB, Enterprise Service Bus, because that's a very old terms. And then since Camel has been there for a while, we've been there for a couple of years already. So we kind of like, we were used a lot in the ESB world. That's okay. But we're not just limited to what ESB is, because ESB is just one big bus, right? With all the brokers inside, and we do all the integration for you. But that's not it, because we are just the framework. So you can use Camel freely on whatever kind of implementation you want. You could do microservices. Even with microservices, you need to do integration. Even with service functions, or you need to do integration as well, right? So there's a need for that, and Camel just does that. And I don't like people using the word ESB related to Camel or ETL related to Camel, because we don't just do that. Like, we can do everything. We can integrate microservices for you.
So
You need
actually,
that, right?
Not that you have strong feelings on this or anything.
Right.
In that point, it's I actually hear people saying that, because I'm doing microservices, I don't need all this garbage that you're telling me that is actually in ESB. But the problem is that we tend to link ESB with this monolithic central deployment specific team in the organization that needs to deploy a monolithic application server or so on. The difference is that was the deployment model, but still what we need to do is what we mentioned, right? Being able to have these connectors to link to external systems, also being able to transform these data payloads from one format to another, or just do mapping. That are things that you still need to do on a microservices approach. The difference is that instead of having all those transformation, all those routes, all those flows in a centralized place where you need to go out there and do all this heavy lifting and then get back, the idea of Camel is because it's something that you can embed in your own application. Obviously, you can embed that in your own microservices, because also Camel is very lightweight for these kind of things. Then so you can continue using the same technology, because there's all the goodies with the enterprise integration patterns, but also being able to deploy on top of your microservices and still get the same benefits.
Exactly. And speaking of that, I think one of the things that Camel brings into the picture with Kafka is that Camel community is now working on something called Camel Camel Connectors. So the problem of that is because Kafka only talks in Kafka, right? So how do you get information into Kafka and out of Kafka, right? So a lot of people, they don't know how to write, Camel DSL, and they're not, big fan of Java, all that. So the way that Camel community helps connecting to Kafka is that we provide a connector for you to actually stream your data into Kafka, so the other system can take advantage of that and start using it. So that's what Camel community has been working really hard, is to add that, the expand of the amount of components that Camel has, the amount of connections we can bring in and take that into Kafka, so that your system or the system can start consuming data from Kafka as a single format. So they don't have to care about, should I use this library or should I use that library? No, you don't, right? And then that kind of brings us into this new era of, event-driven architecture, like what Hugo said, because now I think people are getting away from just the APIs, because API is just a synchronized, communications, and then there's a request and reply. But how do I do a publish? How do I just publish my events, publish one of my events, and then every consumer gets it, right? I don't want to do like calls every single time. I want to make sure that, once I publish this, people wants to know this message gets it. So that's why, like, it's a lot important, like in the nowadays world, that where Kafka can help you to become that medium to actually broadcast your informations. Yeah.
So you can have messages fed into Kafka,
Right.
and have Camel sitting at the other end pulling stuff out of Kafka, mutating it into the format wanted by this system, and then by this system, and then by this system, and then that handles the fan out.
Exactly.
Yeah, it's pretty important. One of the things that I perhaps didn't mention about Kafka is that for Kafka, to be so able to scale and so able to handle the throughput, for them, all the messages are just a byte array. So Kafka really don't care about the message. It's just like a byte array. It's a chunk of data that comes. So if I'm a consumer or a producer for that information, how do I deserialize that information that is just a bunch of byte arrays? And how do I transform to what I need? So you will need to certainly be able to have these things around, schema management, that it's actually the contract for event-driven architecture. Because when we're talking about APIs, most of the times we just think about REST APIs, but actually API is the contract, so that's the name, interface, to be able to access some resources. And one of the things that we have been pushing like a lot is, for example, the contract first approach. And one of the things that you need to think about is also the contracts for your event-driven architecture, for your topics, for your information. And that's most of the times the schema, right? So when we're talking about REST API, we're talking about open API specification that gives you information about the paths, the methods, as well as the structure of the payload. In the case of topics, you also have something very similar, like the seek API specification, that it's very similar to the open API that tells you, okay, this is my topic, and most important thing, this is the schema that I'm just sending through that topic, and just are the different versions, and this is the way that you need to serialize that for Kafka to be able to be consumed somewhere else. So Kafka, it's just a way to move that data. But at the end, as you mentioned, Larry, Camel, it's a way to have out of the box more than 340 different components or protocols that allows your Kafka architecture to be able to talk to almost any kind of system, right? For example, I want to capture information that comes from a Slack channel and then just make it flow through Kafka. Then I need certainly a Camel connector that knows how to speak Slack. I don't need to even look at the Slack API. I just need to configure, what is my token, what is the endpoint that I need to connect, and that's enough for Camel to be able to, plug into Slack, get all the messages, do the serialization correctly into like JSON or Avro or any other type of serialization format that I want to use in my topic, and then being able to send that information. And the other way around, if I just need to send that message that is coming and flowing through Kafka that perhaps is being transformed or it's being done some magic with that in the middle, and then I need to push out, for example, to Google Sheets, then Camel has a connector that allows you to just configure what is your token, what is the Google Sheet that you want to connect that, and then just take that information that's flowing through your topic and send it back to Google Sheets, for example, or any other of the more than 300 connectors that you have already available out of the box.
So if I want to do something like that, where I've got a Camel on one end pulling in data and sending it into Kafka, and then Camel at the other end pulling data out of Kafka and sending it to all kinds of places, do I need two Camel instances, or do I have one Camel instance with multiple pipelines configured?
You can do it both, but I highly recommend you to separate it in a microservices spirit. So you don't want, because they're all doing different things. So for me, if I want to do some updates on this side, and sometimes I want to do some updates on this side, it would be better to have two separate instances running it. And they're super lightweight. So I don't think having them in two different instances can, that would make any difference.
So actually, yeah, one of the things that we mentioned at the beginning was that there's different type of run your Camel routes, as we call them, right? You can have this ESV approach where you have everything running on just one single VM, Java virtual machine, and everything is running there, and you have all the benefits of a monolith, but also all the drawbacks of a monolith. Or you can have the other type of approach that is, this distributed approach where everything is running as even not as a microservice, but even as a function that is very specialized on handling something. So Camel gives you both options, right? You can't just have everything on one single JVM running on top of that, or you can use the Kafka Connect API to have the delegation of this management to the actual Kafka ecosystem, or you can just run them as independent microservices that are deployed on their own container images or their own Java virtual machines, and then being able to, connect, extract, and do all the different workloads that you require.
Yeah, that's a great question actually, because I've seen people doing 10 different routes in a single application. I mean, it works, but maybe in the future, if you're doing that, maybe just try to separate out your routes so they can work independently from each other. If you're a Camel developer watching this, make sure that separate out. Don't do them all together. And because the thing is that because most of people don't get is integration is supposed to be stateless. And I think people doing the whole big chunk is because they want to store some states. That's why they want to store some things in a bin so they can keep using it and all that. So don't do that anymore. Like this is not the way. So if you want to like pass on stuff, you want to do your states, don't do that in the integration. Integration is supposed to be stateless, right? So that's one of the things I see people doing a lot of time, right?
Okay, so we have a couple of questions in the chat. This is wonderful. We have one from Ricardo Ferreira. I hope I pronounced your name correctly. Important note that Kafka has built-in connector architecture called Kafka Connect, which includes hundreds of open connectors available. So use Camel when some connector is not available there. So it sounds like Kafka and Camel overlap here.
Actually, it's not. So I already mentioned about Kafka Connect. So Kafka Connect is just the framework and the API that allows you to run connectors on top of that, right? So there are two different things. One is the Kafka Connect API, that is the platform where you can run connectors. Then we have the connectors. So you can have a Kafka, the Kafka Connect API being actually stripped naked, because actually under the Kafka, under the Apache project umbrella, there's only one connector, and then there's a lot of projects outside creating this connector that and then run of Kafka Connect. Camel has the ability to run independently, standalone mode, where you can have your own applications, or you can also have the connectors that run on top of Kafka Connect natively, where you just need to configure, you don't need to code anything at all. This Java DSL, except you don't need to think about that. You just configure your Kafka Connect class and configuration for your connector, and you are done. Obviously, that's a limit to the space because, for example, using the Kafka Connect API, you only have what we call the single message transformations, right? It's very specialized things to do that obviously are stateless, that they're not able to connect to other systems, and so on. And that works pretty well for several use cases, but where you actually really need something more complex, like doing this enterprise integration patterns where you need to split or aggregation or so on, then Camel, it's obviously a better suited tool, but it's not a limitation that you need to use one or another. Actually, you can have the benefit of running both at the same time even.
Okay, that actually dovetails nicely into another question we have here from someone whose name is not in a Latin script, so I'm afraid I have no idea how to pronounce it. But they're asking, are there drawbacks to using Camel, and what alternatives are there? It sounds like Kafka Connect is an option for the simple case. What other, when other cases where do you want to not use Camel, and what would you do instead?
I would say sometimes, how do I think of a place not using Camel? I use Camel all the time, right?
The hard questions are
Right.
the most interesting.
Exactly. Like how would I not use Camel? Well, probably one of the things I don't use for Camel is probably pulling state change from databases. There's other project called the VZM that does that because it does that pretty well, reads all the changes in database and then reflect that into Kafka. So that's something that I probably won't use for those type of integrations. But most of the case when you're trying to connect from one point to the other, I think Camel can pretty much does that thing for you. Even with the larger, I see people do the larger file load. When you load large data and when you're trying to do streams into other places, the problem is that when the data gets too big in Java, you have to stream it, right? And there's a lot of memory consumptions and all that. But in Camel, there's a caching and there's streaming. You can enable that, so it will partially load your data and then start processing it. So you don't have to have that large consumption of resource. So we can do that in Camel. So I don't think there's a lot of things you Yeah, so I would probably use Camel most of the time for integration, that kind of use cases.
But it's
But
also,
like, yeah,
you mentioned too there where if you need to maintain state for some reason, that's not really what you should
right,
be doing.
exactly. But
And
integration, you
if you
don't
had,
do states,
yeah,
right?
if you're doing
So
like
Yeah,
polling for
exactly.
like a database changes, you're saying should also, that's not really Camel's
right,
approach.
And
exactly.
also the approach where you have like terminal operations, that's like, okay, you access that and you don't do anything else. Perhaps Camel is not suited at all. Even for example, when you're REST services that you need to answer back, that's suitable. But if you just want to, get something processed and then just do nothing else, perhaps Camel might be not the best tool to do that. Even though it could be used for that, we're saying that obviously, as Christina said, right, you can do everything with Camel, but perhaps it's not that suitable. It's not the best option. You might find something different
It's like
on that, right?
if you're pulling data out of a Kafka stream, doing some kind of, read 15 or 1500 records, compile that into a single object, and then save that to an SQL database, that's not really Camel's area.
No, that's actually one of the best things to do because you're moving data from one place to another, doing patterns. The difference is, well, like if you just need to, take that information and get just the compilation and then just do nothing, right? So that's kind of things where like I just need to be aware of something or just need to, refresh a UI. Those kind of examples are the things that perhaps are not the best suited ones.
Yeah, and one of the things I can think about like right now is that, I see people doing RESTful services with Camel. But I mean, there's sometimes you have to do like, page rendering and all that. That's better for web applications. So that's something that's not really good for Camel. So if you want to do web applications, like displaying HTML and all that, probably not the best thing for Camel. Camel is just moving. Camel is this animal that moves things from one point to the other. So it's not best for presenting.
That's where the name comes from.
That's where it's coming from, exactly. Yeah. So it's best for a Camel to move things, but it's not for presenting things on on the web page and things like that. It's not for Camel.
You mentioned before a bin and something. You didn't freak out when I talked about aggregating data together. So does Camel have state capability to pull in, say, I want to pull in 100 records at a time from Kafka or REST API or something, and only after I've got 100 of them, do some computation on that to produce some kind of single output from all those 150 or 100 messages or whatever. How does that work in Camel? Does it have that kind of state memory storage capability, or is it strictly one message to one message mapping?
It'll be one message to one message, but there's one message to one message mapping. So for Camel, it's just one message flow through this route and then goes to the other places. But storing states, there's other patterns we can use. There's other patterns where we can cache it and then we can pull it out later when we get the next message, and then we can send it over. So there's other there's patterns we can use for this kind of situations, right? So I don't think that's a problem for Camel.
So one of the things that Camel can do for these kind of patterns where you actually need to store some kind of state, it's being able to have these connectors to resources that allow you to store that state. For example, there's a Camel Redis connector, there's a Camel Infinite Spec connector if you want to use a cache, for example, to just store information and implement things like the idempotent consumer or other type of patterns, or as we can even use Kafka as a way to store the information, and then you'll be able to process that or just connect to other systems or frameworks that allows you to do this kind of state storage. But most of the time it's just a way to feed those kind of systems, and rather than storing everything, because obviously you can do that everything on memory on the same Camel route, but you will get to that point where you won't be able to scale further, and then you will need to rely on something that is more suitable for those kind of things.
Yeah, and idempotent can be very slow when you talk about microservices cloud development, right? So because you need to make sure that there's only one copy of your cache, right? So I want to make sure that that's why I talk about stateless for Camel, because that's the best way you can implement, so it goes a lot faster. So you don't have to think about checking the cache, coming back, and all that. So that's what I would recommend. So yeah, Camel is not good for stateless, But if you want to cache stuff, you can do that with Camel.
Okay, so if I wanted to do something like I'm streaming my web server logs through, say through Kafka, and every hit, HTTP hit is a Kafka message, and then I want to do like hourly analysis and say, all right, grab an hour's worth of data at a time, or 1,000 messages at a time, or something like that, and do some kind of transformation on that, so I can feed an hour's worth of data to an analysis system to determine if I'm getting a DDoS attack. I'm making this up on the fly, so maybe it makes sense, maybe it doesn't. That, yeah, I can do the storage of the messages in Kafka. I can do the convert those text messages to whatever the data analysis tool wants using Camel. Where do I do that buffering of I want to grab 1,000 messages at a time or an hour's worth of messages? Would that be a second Kafka queue? Would that be one of this buffered Redis-based connectors in Camel? Where would I put that part of it?
What I would do is I will create 2 different Camel routes, right? So for one Camel route, it will just streams data into a, say, Redis or whatever cache that you want to store in, right? Or database, whatever, the storage. And then I have another Camel that will then, be a timer or whatever that was, and pick up this information and then just sums up all the hour time of information and then send it off to other place. That's what I would implement with Camel. That's how I would do it. So I won't be storing anything in the Camel route, because what happens if it fails, and then what if I lose my data and all that? So I would probably do it, right? So that's the way I implement it in Camel.
Okay, so Kafka to Camel to some kind of data store, right. Then a connector on a second Camel that does a select 1,000s at a time, and that is a message. That 1,000 chunk is a message.
Right, but currently what I see from the streaming and Camel processing is more on the real-time purpose. So it's more like a behavior detection, right? So if I'm seeing a behavioral type of the information keeps coming in, so Camel will send this information, and there's a mechanism there that's like detecting the behavior of these streams of data, then I would probably send off alert and stuff like that. So that would be more like a real-time processing rather than waiting for an hour and caching and all that kind of thing. So that's kind of
if you're on a busy site, then 1,000 messages, 1,000 log messages is a minute and a half.
Yeah,
it's a big site we're talking about here.
Right.
So that's close to real time.
Okay, yeah.
Okay, Robert Douglas mentioned something that's really cool. So please describe some real life projects that are using both Apache Kafka with Apache Camel to us.
Real life project. Do I know any? Are we allowed to say customer's name? No, we're not, right? Well, we can.
But I know one. So we have this big parcel and transport company that needs to handle a lot of communication almost in real time. So for example, if you buy from Amazon and you were expecting somebody to deliver your package, it's actually a transport company that is doing the parcel and the shipping, right? So they need to have this kind of next to real time communication. And they use this type of components to, get feed of the information from the GPS location, the GPS location from the transmitters on the bands that are, carrying the packages, send that over to Kafka, being able to analyze if your package is coming. So then they use Camel to then connect to the email service that will send you an email saying like, oh, your package is going to arrive on 3 hours, or it's already at your door, and then they just plug into take a picture, send it through Camel to Kafka, and this is going to get back to you as part of your email or your information. So the shipping and parcel companies are one of the most common use cases for this kind of things, where you have to do tracking, and because all the events need to be in order, and Christina mentioned Kafka allows you to have some kind of order to get those events as they occur. It's one of the things they want to do, like, for example, tracking packages, right?
Wow, it's a good one.
Also, another one is in any banks, for example, where you need to connect to these mainframes or all the processing cores. You also again get the benefits of Camel to being able to talk with these all legacy protocols. You can use the TCP connector from TCP connect component from Kafka, from Camel, and then being able to read the datagrams, TCP datagrams that are coming from that socket, and then being able to send that message already transformed into a database, for example, or of Kafka or any other system, and then being able to be consumed by more modern type of applications through the Kafka protocol or through traditional AMQP type of communication. So those are, for example, those of the examples that just pop up into my mind.
Yeah, and then there's banks. What was it? The banks trying to talk to Swift. There's messaging transformations, and there's Amadeus. Have to talk to the systems and all that. So yeah, things like that. You can do a transformation of data, integrating contents, and all that kind of stuff. You can actually work with them. So, and there's another one. Probably not good to talk about. So yeah, that's it.
So is Camel pull-based, push-based? Can I issue a request to Camel and it forwards a request on and then transforms the data back? Or is it just, it sits there and is going to be pulling data from one source to push out to another?
So there's a couple of different scenarios for it, depending on the source that you're listening to. So there's push-based, there's pull-based, and there's timer-based. So there's different ways, or webhook and all that kind of stuff. So you can actually, depending on the components that you're using. So like for instance, for a serverless one that we have today, it would be more like a trigger base, or will be triggered by them. And then there's other things like pull-based stuff like in Salesforce. There's the pull-based services that we can actually pull from them. So there's like different scenarios. There's different things depending on your services actually. So we have all of that.
So I could do something
like
it
depends on the
timing problem.
I would say it depends on the underlying technology, right? So for example, if you're connecting to a service that allows you to just connect like a WebSocket and just receive the information, then Camel will be able to adopt that type. But if, for example, you're connecting to a database, then you will be doing pooling, because the database will need to do something more complex to send an event to you on the way back. So it depends on the underlying system. If it supports push, then we would certainly will be able to use that approach. Or if it's just pool based, then that's the one that thing.
Yeah, sometimes you have to create yourself, because if it's a SaaS services out there, is that, for instance, they provide a customer list and they're providing us the RESTful services. So you're trying to pull from it, right? And they don't have any mechanism. They're just a services out there. So you want to make sure that you create your own timer, your own pooling strategy to actually pull from the data, right? So that's something that we can also do in Camel. But depending, like what Hugo said, depending on what the provider provides us, right? If they have a mechanism to do webhook, then we'll do it. But if it's just a plain old services standing out there, then we have to create our own pooling strategies for that.
Okay. So if I want to do like just a translation layer when I'm accessing some web API, where my browser or whatever hits Camel hits web service, and then response comes back and it gets translated each direction. That exactly. Camel can do that?
Yes.
Yes.
Okay.
That's amazing, right. But unfortunately we are over 1 hour. So that was an amazing conversation about Apache Kafka, Broker, and Kafka. So thank you, Christina, to join us on that discussion.
Thank you. I'm happy to be here.
Okay, my pleasure. And also, Hugo, thank you. That was amazing conversation. I learned a lot about Kafka, Camel, and so on.
Glad to be here anytime.
And Larry, thank you again to join us and learn a lot about those tools.
Thanks, everyone.
Okay, So everybody, I hope that you enjoyed this conversation and see you around on the next Deploy Friday next week. Bye. Okay, I'm not sure.